Hello, ladies and gentlemen. For this video, we'll be looking at examples for questions for permutation and combination. Now, just to make things clear, when do we use permutation and when do we use combination? We use permutation when the things that we are going to be written down matters, the arrangement of the objects matter. Okay, so for example, like a password, if your password was ABCD and if you somehow manage to type in BCDA, you will be denied access. Okay, so these two are two individual different passwords. Okay, different permutations. But if we're talking about, let's say, choosing a team, if we were choosing a team of two out of ABCD, okay, if we choose AB or if we chose BA, well, these two are basically the same team. So actually they are the same combination. Okay, it doesn't matter if you choose A first or if you choose B first. In the end, these two are the same team. So this is basically the first main difference between permutation and combination. Okay, so let's look into our first example question here. And what we need to do is we need to identify if it is a password problem or is a choosing team kind of problem. Okay, so in an examination, candidates must select 2 questions and 5 questions in section A and select 4 questions from the 8 questions in section B. Find the number of ways which this can be done. Okay, so let's see. For this part here, is it a combination or is it a permutation question? In this case, it's supposed to be a combination question, okay? Because it doesn't matter if you choose question, let's say 1, 2, 3, 4, 5, doesn't matter if you choose question 3 first and then only 4, or if you choose question 4 first and then only 3. They are both still choosing the same 2 questions. So find the number of ways in which this can be done, right? For the first part here, you are actually supposed to, from the 5 questions, choose 2, okay? In the second part, you're actually supposed to choose from the 8 questions, choose 4. Now, from here and here, the in between the function should be multiply. It's not plus, right? Okay. Then all you have to do is type this into your calculator. Typing this into your calculator, you would have ended up with the answer of 700. All right. Next, the digits of numbers 6, 3, 7, 8, 1, 2, 9 are to be arranged so that the resulting 7-digit number is even. Find the number of ways in which this can be done. Okay, so if they have to be even, then is this a password problem or is it a combination problem? In this case here, it would be a password problem, all right? Then for them to be even, the numbers have to either end with 2, no 4, 6, or 8. And the numbers in front actually don't matter, right? So let's just say in this first scenario here, okay, in this first scenario here, you've chosen the value of 2 to be at the back. So in front of him, you have 6 more numbers to choose from. And then in this case, it will be 6P6. Type this into your calculator. You would actually have gotten just the numbers ending with 2 of this 7-digit here is actually 720 numbers. All right, 720 numbers out of this can actually end with 2. For the next scenario, where it ends with 6, is going to be the same. So it's also again 6P6. And this is also 6P6, where it ends with 8. All right, listing down every scenario will make the question even clearer and more, you will be more able to answer it correctly. Okay, so in this case here, all I actually have to do is use 720, because this is 720, this is also 720, right? Okay, all I have to do is use 720, multiply that by 3. Multiply that by 3, you would have gotten 2,160 ways to arrange these 7 digits so that it will end up being even, right? Now, next question. Find how many 5-digit numbers can be formed using 5 of the 8 digits here. So again, this is actually a password problem, right? So this first part here is very easy. Out of the 8 numbers, you have to form a 5-digit number. So it's just 8P5. And from here, you will get the answer of 8P5, 6,720. Okay, 6,720 will be the answer here. Simple. Next, find how many of these 5-digit numbers are greater than 60,000. Okay, if they are greater than 60,000, let's imagine the scenarios here, all right? Greater than 60,000, the number can either start with 6 first, or they can start with 7 first, or they can start with 8 first. And then the numbers at the back actually don't really matter. As long as there are numbers there, it will definitely be greater than 60,000. So what we have here is, let's say if we started with 6 first, then you actually still have, out of the 8 numbers, you've chosen 1 already. So you have 7 numbers left to find the permutation of 7P4. Type this into the calculator. You would have gotten, this is actually 840. Then it is the same for this, 7P4 if it was starting with 7 first, or it will be same for this when it starts with 8 first. So our working should simply just be 840 multiplied by 3, and this will give you the answer of 2,520. Okay? Okay, next part. A team of 3 people is to be chosen from 4 men and 5 women. Find the number of different teams that could be selected, which include at least 2 women. So, okay, again, we will list them down in different scenarios. Let's say in scenario number 1, where there is 2 women, and then 1 man. So you have your 3-man team here. Okay, this scenario will then be just 5C2 multiplied by 4C1. Type this into your calculator. 5C2 times 4C1. You would have gotten this. There is 40 ways to choose this combination here. But you must also include the scenario where there are all women. Then when it is all women, it also fits under this condition where it says at least 2 women, right? So in the scenario where it's women, and women, then this will just be 5C3. And 5C3 is actually 10. Now, in this case here, we're not going to multiply them together. We're actually going to plus them together. So you have a total of 50 combinations where you have at least 2 women. All right. Moving on to the next part. This is almost similar to what we've done before, but at the end here, you have a different condition. So let's start with the easy question first. A 5-digit code is to be chosen from these 9 numbers here. Each digit may be used once, only in any 5-digit code. Find the number of different 5-digit code that may be chosen. So in this case, again, it is a password scenario. So it's going to be 9P5. 9P5 is going to equals to P5, 15,120. Next condition, the code is divisible by 5. So a 5-digit code that is divisible by 5. Let's imagine this. A 5-digit code, 1, 2, 3, 4, 5, and it has to be divisible by 5. Either you end the number with 5 or 0, but in this case, you don't have zeros. So you can only end the number with 5, right? Ending the number with 5, and then the numbers in front doesn't matter how you arrange them. So in this case here, after taking out one number 5 out, you only have 8 numbers left, and you would have to find the permutation of 4 of them. So 8P4, then this will be 1,680. So there is 1,680 numbers that are divisible by 5. Okay? Okay, in this next scenario here, the code is even and greater than 70,000. Okay, let's start with the first condition here, where it is even. If it is even, you have to end the number with either 2, 4, 6, or 8. Let's imagine the scenario first. 2, 4, 6, or 8. Okay, and the next condition is that it has to be greater than 7. So when it is greater than 7, the first number must be 7, and then either 2, end with 2, or 7, then end with 4, 7, end with 6, 7, then end with 8. In between, you have 3 more spaces for your 5-digit code. That doesn't matter what number you put in. Okay, so let's just imagine this first scenario here first. 7, and then let's say you choose 2 at the end. Then in between, you still have 7 numbers to choose from to fill in 3 slots. 7 numbers to choose from. 1, 2, 3, 4, 5, 6, 7 to fill in 3 slots. So it's 7p3, right? 7p3, that's 210 for this combination where it starts with 7 and ends with 2. Now, the working would exactly be the same for this. So it's 210 if you start with 7 and end with 4. If you start with 7 and end with 6, you 210. If you start with 7 and end with 8, you will also have 210. So in other words, it's just basically 210 times 4, which will give you the answer of 840 if you started with 7. Now, in the second scenario, where it is greater than 7, it's not just, you don't have to just start with 7, right? You can even start it with 8. But when you start with 8, you will realize that the numbers at the back, you will not have 2, 4, 6, 8. You only have 2, 4, and 6. And in between, 3 numbers here. All right. In this case here, again, it is after, let's say you start with 8 and you end with 2, you still have 7 numbers to choose from. Again, 7p3 in between. So we already know that this is 210, right? And 210, we use that by times by 3. 210 times it by 3, you have 630. And lastly, the last scenario is that you start with 9 and you again end with either 2, 4, 6, or 8. In between, 7 numbers to choose from for 3. So again, 7p3. Then this is the same thing as before, 210 for each, 210, so a total of 840. Now, the final answer would simply just be 840 plus 840 plus 630, which will give you 2,310. Right? If you were to break it down like this, you are more likely to be able to answer the question correctly. Okay. Looking at your next question. A team of 6 people is to be chosen from 8 men and 6 women. So again, if they're already chosen, then it's going to be it's going to be a combination question, right? Find the number of different teams that may be chosen if there is no restriction. No restriction meaning to say anyhow from these 14 people. So it's going to be 14C6 because you're choosing a team of 6. So 14C6 is going to be 3,003 people. Now, in this second question, there are no women in the team. That means all 6 of them has to be men. Then it will simply just be 8C6. 8C6 in the calculator is going to be 28 combinations, right? There are going to be 28 combinations. Then lastly, there is a husband and wife who must not be separated. So let's just say if the husband and wife were to be chosen into the team, then that would be scenario 1. A team of 6, 1, 2, 3, 4. Then the husband and the wife chosen in your team of 6. From here, then how many are you left with? You're left with 12 people to choose from in the team, and you must select 4 of them. So it's 12C4. All right, this is the scenario 1 where the husband and wife has been chosen. But there can also be a scenario where the husband and wife, 3, 4, 5, 6, where the husband and wife is not chosen in your team of 6. Okay, then in this case here, if they were, this is also fulfilling the condition where it's not separated, right? So from here, what you have to do is you have to use 12C6 because you're not choosing from with the husband and wife in the pool. So it's just 12C6. And then in the end, plus these 2 answers together. So 12C4 you would have gotten 495, and 12C6, you would have gotten 924. Plus these two scenarios together, you would have gotten a total of 1,419 combinations where the husband and wife are not separated